So it's an honor and privilege to be here in front of everyone today to talk about creating a zero defect movement. I'm going to try and do my best to paint a little bit of a picture here for all of us in the room about my journey with zero defects, about my journey with AESQ, and how what I think is a really well thought out and strategic initiative that the industry has taken. And we're seeing the fruits of that the last 10 years, but really expanding upon that and how we continue to persevere through all the challenges that we're going to face as we continue. So I was a new college graduate coming out of an engineering school. I got lucky and joined a fuel nozzle manufacturing business working on aerospace components. The first task that they gave me was to create a process FMEA on Trent 900 program. Okay, I'm 22 probably at the time. I knew what the term meant. I knew what PFMEA meant, didn't know how to do it. So like any, good scholarly person, I picked up a book and started reading, but there was a lot of things that the books don't tell you. So I jumped in, formed a team. First reaction of the team, you want me to do what? You're going to sit me here for 2 hours over the next 3 months and we're going to create a PFMEA? That's your job. Go do it. Okay, thank you for the feedback. Let's take another approach at this. Ultimately, though, what ended up happening was I had to create a PFMEA with the team, and just close your ears for a minute. Horrible PFMEA. Looking back on it, the worst probably PFMEA that's been done in the aerospace industry. I will take full credit on that. But the point being, we didn't know how to do this. We had a task where, a lot of leaders, much like a lot of us in the room, said, this is a great idea, go do it. When it comes down to fundamentally performing the tasks that are all around this room, all of the reference manuals that we have in this room, it's not easy. It's not something that naturally comes to a lot of our individuals in our organizations. It's something we have to take as an adventure. And I put up there, it's just beginning. Trent 900's been around for a long time now. That fuel nozzle has been in production for a long time and now in aftermarket support. I'm still beginning on my adventure with zero defects and the journey of getting to zero defects. Fast forward, I was still in the same organization, had worked my way up a little bit, was a quality manager. I heard this new concept that was coming. The industry is creating a common specification for us to work to. Being a little bit skeptical, I kind of snickered to myself that, okay, I'll believe it when I see it. Was working to Pratt expectations, was working to Rolls-Royce expectations, was working to GE expectations. Every single one of them had different expectations. So I was a little skeptical on what exactly we're going to try and accomplish with this industry consortium. Again, fast forward, we have the blueprint for how to achieve zero defects that is given to us as an industry. It's up to us to actually take the action and enable our teams to be able to be successful with the reference manuals that we have around the room. The adventure is just beginning with the reference manuals as well. We're at Rev A. We'll soon be at Rev E, I'm sure, within a few years, because we're going to continually learn. That's what we do as an industry. I was having a conversation a little bit ago. It's amazing to me how impatient a lot of our organizations are for such a long cycle business. I keep reminding my team that I haven't really ever met an engine program that died. There's somebody somewhere that's going to pick up an engine and say, I'm going to put this in a new application and use this. So our fingerprints always have a lasting impression. And what we're working on today may be something that a 22-year-old in 30 years is going to have to pick up. That's our legacy. So it is an adventure. The point being, we can't look at this as a point in time. It's a journey. We are all learning together, but we're just starting. We just got done fueling up the car, and we're getting ready to turn onto the interstate. We have a long way to go. One of the most entertaining for me interactions that I have as a quality leader. So let's set the stage a little bit. So we're going to ask the generic question, who all is responsible for quality in the room? Everybody put their hand up. I know you guys just had break. Thank you. We're all responsible for quality. Now, getting down to brass tacks, who is actually fundamentally responsible for quality within your organization in the room? Raise your hands. No, seriously. Who is really responsible for quality? No, I'm kidding. The point being, one of the most entertaining conversations that I get to have as a leader is articulating this message of zero defects. And the reactions that I get, I mean, it is entertaining. It's like watching a movie. Sometimes I know what the ending is, sometimes I don't. But you'll get this kind of visceral reaction. Somebody kind of stands up in their seats and says, you want us to achieve what? Zero. How much are you willing to pay for it? I'm already paying. First point. Second point, yeah, I do expect you to hit zero. It's that fundamental expectation and setting that expectation with our teams, more importantly, with our leaders, our peers in our organizations, our CEOs, our presidents. It's setting that expectation that zero is achievable and will be done. It comes with a caveat. It's not going to happen tomorrow. Back to my impatience comment. It's not going to be tomorrow that this happens. We're setting the foundation today for what we expect to achieve in 20, 30 years. We're performing the tools of APQP and PPAP today so that we can see success when a program goes into service 10 years from now, 5 years from now. It may never go into service. It may never go into operational use. We're still doing it because it's the right thing to do. And I would argue that every opportunity we have to touch one of the tools within the suite around the room is an opportunity for us as an organization, as an industry, and for our team members to learn something unique about our manufacturing process. One of the biggest fallacies of zero defects is that we did it. We completed a PPAP package. Why did we have a defect? Why did we have an escape? Anybody venture to have a guess? Can't predict the future. We cannot always see around every single corner. So our reaction as leaders, and this is going to come up later, our reaction as leaders when we do have an escape on a program, we've seen people be completely signed off. Everybody's signed, sealed, delivered, ready to go. There's an escape. That's an opportunity for us to learn. Not an opportunity to chastise, not an opportunity to belittle, not an opportunity to question, why didn't you catch that the first time? It's an opportunity to learn. The biggest failure we can make in that learning opportunity, though, is not leveraging it on all the other programs that are going to come after it and have come before it. That, I think, is a failure. So if we see a manufacturing process that, we expected to have zero defects on, and we have human factor element that causes an escape, we don't blame the person for that human factor. We blame the process. We put a process control in place, and we read that across to every single program that goes across that process. That's fundamentally what I want us to take away from this entire package, this entire suite of tools. It's not about perfection today. It's about the journey to perfection. I talked about long cycle business and what that looks like a little bit earlier. We don't have engine programs that necessarily just go away. I was surprised to learn when I joined GE Aerospace, there's a lot of old programs that we're still having to deal with. I spend a lot of time in Lynn, Massachusetts, manufacturing T700 engines. You would think of all the T700s GE Aerospace has produced, that we would be really good at it. Safety record's great. I want to put that out there first and foremost. It's a lot of brute force effort to get those T700s out every year, every day, every month. Fundamentally, we're not going to change the design on a T700 engine. We're not going to go through a new product introduction cycle on T700. So how do we define a quality culture? How do we implement zero defects on a legacy program that has been around forever? It's actively working to find an application of one of the tools in this room, problems. Are we back? Or we're back? Okay, that's really loud, sorry. It's finding an application on what's causing us issues today. Don't wait for that NPI cycle. Don't wait for the redesign that you may think is coming in 5 years, in 2 years, in 6 months. Don't wait for it. Encourage the use of the tools to solve the challenges that you're having today. Yes, Nirvana. I want to talk about that for a little bit. The ultimate goal is to have a design FMEA that feeds into a process FMEA, that feeds into a control plan, feeds into a capability study, MSA, all of those things line up. That works when you're an automotive manufacturer and you get to throw away your design after 7 years. Does it work when we're producing a 30-year-old engine? It may not. We may not have the opportunity to have that design FMEA to feed into the process FMEA. I would argue with anyone in the room or anyone in the industry that by still doing that process FMEA, doing it the right way, having the design engineer in the room, going through that activity on that legacy design is still 10 times more valuable than waiting for that design FMEA to come, because it may not. Our design engineering teams really like to focus on new things. It's in our tagline, we define the future of flight. Well, that doesn't say a whole lot about the 30-year-old design that we're having to deal with, right? So go through that activity. Encourage your team to really question. Yesterday, we expected to produce 20. What was our actual condition? Let's say we produced 5. Why did we not produce the other 15? Well, that may be a quality issue, a quality defect driven from a manufacturing process? You continue to ask that question, and it's the same cause. Wouldn't it make sense to go do a process FMEA on that feature that you're trying to produce that's causing you an issue and setting the foundation at that level? It doesn't mean we have to go through and do a process FMEA on the entire hot section. That's not the case. Go do it on that feature. Go learn. Go get your hands dirty and learn how to do this and see how effective it can be. In a lot of cases, the industry has been, I know some of us in the room have been feeling the pain of this. A lot of our designs have been around for a long time, and inspection technology is becoming something that is well outpacing manufacturing capability. We have tools like blue light scanning. We have tools that can tell us the minute surface imperfections of anything that we're producing. That's fantastic. It's great. As a true quality engineering nerd, I love that. We have to be careful with it, though. Measurement system analysis. Ask ourselves the question fundamentally, what's our measurement system analysis telling us of our current inspection methodology? And let's make an intelligent decision about how we apply new technology when it needs to be applied, when we have the opportunity to apply it. There's a piece as well that comes with really working with the design community to make sure they understand what it's going to tell us, what it could tell us. There may be certain things that we never knew. Surface conditions that we've been using for many years that light can give us details on we never knew. The point being, we have to be methodical in how we implement and roll out these tools. But to wait or to wait for, I'm just going to stand here. There we go. To wait for the tools to actually filter through our business in traditional methodology of new product introduction, change in design. It's the right place to start. We have to get back down to a more fundamental level and engaging with every single quality manufacturing engineer, design engineer in these tools around the room to really create a quality culture. The second piece of this that I really want to focus in on is around the aspect, and we've heard this already this morning, this aspect of leadership engagement. Myself as the global quality leader for GE Aerospace, I came into the organization and I preached APQP from day one. I'm not confident that I did the homework to educate everyone in the room on what APQP really meant. So for us to really be successful as an industry, it's going to take the CEOs, the presidents, the ops leaders, the purchasing managers, everyone in the room that's sitting around that boardroom table having the conversations to be driving a zero defect culture. We have to teach them. It's imperative on us to teach them what that means and how that becomes effective within each one of your organizations. The blueprint is here, but there's a little bit of connective tissue that the blueprint doesn't give you. And that's where each one of our organizations is unique and diverse from its history, its makeup, how the structure is set up, even who is running it from, a P&L perspective. Is it a publicly traded company? All of those things have a factor on how well or how you define your zero defect culture and how you implement a zero defect culture. So the blueprint is in the room. We don't have to go through in great detail with me about why every single one of these tools has a huge impact. As leaders, where we make the biggest impact is tailoring the approach for each one of these tools to our organizations. I love movie quotes. You'll see I'm walking away from my microphone, sorry. I'm back. The first line there, be the ball. When I was thinking about this, I thought nothing more fitting than Caddyshack and Chevy Chase standing there trying to teach the younger golfer exactly how to putt the ball. Be the ball. Zero defects is the ball. Let's be zero defects. Let's believe in it in our core. Believe in it that it's something we can achieve every single day, and take forward to our leadership teams this idea that zero is possible. We have to make sure to celebrate. Oftentimes in our long cycle business, it's a conversation about what have you done for me lately. It's fantastic, you got that PFMEA done, now go do another one, thanks. Don't act like that. Celebrate these milestones in your organizations because they are huge milestones. If you're tracking escape count and you make a 20% reduction, you see a consistent 3-month trend and a 20% reduction, celebrate the hell out of that. If you track RPPM and you consistently see a drop in RPPM over a year period, I would argue that entire team's getting a little bit more than a pizza party. The team responsible for that, you have to celebrate it. It's important, and it drives, first of all, it drives it's not easy to do this. It's not easy being the quality engineer in the room trying to facilitate a process FMEA. We have to give some credit where it's due to those individuals. The next one up there, pivot. When we think about the way, I'm gonna bring you back to my story. Trent 900, I learned a lot through APQ, I'm air quoting now, APQP, implementation on that fuel nozzle program. A couple years later, we won the XWB fuel nozzle program. Full circle, go do APQP on that program. That was a barrier of entry for Rolls-Royce for us to be successful. When I went back to that same team, I didn't go back with the same strategy. I had to change my strategy because I knew having 7 individuals in the room sitting around a table, at this point phones weren't necessarily a real thing and we didn't bring laptops into a meeting room, so that wasn't a problem. But they definitely weren't with me during Trent 900 days. They were often something else. They were thinking about whatever they were doing that night, or that weekend, the next family vacation. They had their mind somewhere else. So I had to pivot. And I didn't approach PFMEA on that program in nearly the same way. We would have 6-hour marathon PFMEA sessions on Trent 900. I kept every single one of those sessions to an hour or less. We just did a lot more of them. So the point being there's not a one-size-fits-all approach. I think I've said that a couple different ways now. The tools all work the same way. How we implement them is what all of us in this room get paid to do. When we fail, we have to learn. It's an opportunity for us to really come full circle and be humble enough to stand in front of a leadership team or peers as engineers and say, you know what, we missed that. We didn't recognize that that failure could happen. Truly going back and learning from that is the opportunity. Yes, there's going to be some tense conversations. There's going to be some irritated people in the room. There's going to be some leaders that may pound their fist on the table. At the end of the day, take that as an opportunity to learn, pivot, celebrate the fact that you could learn that, and fundamentally go all the way back to the beginning. Still believe it's possible for zero defects. Don't let a miss on a risk identification cause the team to not believe zero is achievable. I had a quote in there by Winston Churchill, but essentially what it's saying is, definition of success, thank you, I'm back, hi. I'm a pacer, so this is a challenge for me. This is me outside my comfort zone. We have to continue to persevere through failures. That's the message I want you to take away. Because we talk a lot about zero defects, and a lot of the leaders in the industry may still be skeptical of what zero defects is, of what zero defects can do, what the culture of true quality can be. Don't let that get in the way of asking the right question of your team tomorrow. Don't let that get in the way of setting the right strategy next year. Don't let the issues of today define what it is that you're going to go do tomorrow. With that, I'm going to turn it over to Ian.